Hi students, welcome to ALPHORES e-learning program. Have a glance on this tabular form. Of course, you are finding new names. Two new names you found here, those are domain, range. Okay. Now, what are these new terms? Domain and the other one is range. Domain means actually if you define any function, suppose sin x, whatever values x you can substitute so that sin x is always a real value. Suppose if I write square root of -3, this is not a real value, and if I write some finite value divided by 0, this is known as undefined tending to infinity. That is why here whenever you come across these kind of non-real values, then we say those are not in the domain. That means we are doing here according as real numbers only. So, as far as real number set considered, now the function is defined for what values of x. Defined in the sense what? You should not get any imaginary values or undefined kind of values at the same time like this indeterminate form values also. So, that here we are going to take domain, the new term, it is nothing but set of all values of x such that f of x is defined for all real numbers or some restricted values of real numbers. Now, sin x domain means x values. So, you are defining what values of x are suitable. So, for sine function those x values are nothing but here real numbers, and these already we have observed. For cos in the same way x you can substitute any real number, and for tan we observed it is nothing but sine by cos. Whenever you write sin x divided by cos x, the denominator must be not equal to 0. Hence, where the denominator you can obtain 0, whenever cos is taking all odd multiples of pi by 2. So, all the real numbers except which one? Odd multiples of pi by 2. And cot, what is cot x actually? Cos divided by sine. Therefore, here sin x should not be 0 because it is in the denominator. Hence, what we have to take? All values of real numbers, no doubt. At the same time, sin x must be here not equal to 0. So, sin x not equal to 0 means which is not n pi values. That is why from total real number set you have to delete all n pi type of values. And cosec, cosec means what is the value? 1 divided by sine, and in 1 by sine or here both denominator you observe sine function. Here and here if you observe sine function in denominator, that is why these two are having same domain. And again here tan is sine by cos, secant is 1 by cos. Both are having same denominator, that is cos x. In denominator this is tan and this one is secant. So, this value shouldn't be here 0. So, cos x not equal to 0 here and here, that is why these two are having same domain. Sin x not equal to 0 in denominator, hence these two are having same domain. Now, let us consider range. Yesterday we have observed graphs. Now, these values, sine values, however x largest or smallest you substitute, but you will get always in between -1 and +1. Similarly, for cos also both are same, whereas tan we have observed it is all the real numbers. Now, what is the new term? Range. Range means if you substitute values from the domain set, then what about all our answers? All our answers they will be here in between -1 and 1. We call another term as the set of all images of any function is nothing but range. Therefore, here whatever x you substitute from the domain of the function, answers whatever you are getting here, those are all coming under range, and that simply we call them as images from the domain set. And now here this tan x range is all the real numbers, range all the real numbers, whereas cosecant x we observed the graph is above +1 or below -1. Secant also same, above 1 and below -1. So, this is known as here range. That means if you take values from domain, and if you substitute here, then finally what is the range from where to where those trigonometric functions can take values. And these yesterday we have observed roughly, just a shape of the graphs only I have taken, I didn't write any values on x axis. I think you can understand only shape of the graph is important. And next these are here period of the corresponding functions. So students, once you know about this one, very important, in many problems we kept on using this range values as well as domain values. That's why just again feed this tabular form completely in your mind computer. Okay students, now let us do some problems basing on this domain, range, etc. Dear students, let us check here these 5 problems. Let's solve one by one. Observe here the first problem given as an angles given, sin theta 1 plus sin theta 2, like that, an angles given. Now they asked you about sigma cos theta I is from 1 to n. Earlier we observed about what is the nature of this sigma, how to write sigma values. I value if I put cos theta 1, after every substitution put plus symbol, cos theta 1 plus cos theta 2 plus cos theta 3 etc. plus cos theta n. So what is that value under this condition? Now here how many terms are given in the left hand side? Altogether n terms are given. So once n terms are given, then if you substitute, they did not mention theta is here positive, negative, or else acute, obtuse, right angle, nothing given in the problem. Now how to find here value? Generally whenever this equation is given and they are asking, means we think actually individual values can be obtained. If I take here 1 by 2, suppose theta 1 30 degrees 1 by 2 and theta 2 suppose 60 degrees root 3 by 2. However you add all the values, you can't get exactly n, and clearly you can observe n you can get only when each of the value is 1, then only it is possible. In any other case it is not possible. What is the reason behind it? The reason behind it is, you know, minus 1 less than or equal to sin theta less than or equal to 1, however theta value real number you substitute. Therefore minus 1 to 1 is the only possibility for sine value, and the RHS can come only when each of sine function is 1. Then if you substitute here 1 plus like that, how many ones exist left hand side? N ones exist, and therefore the equation exactly balance. Don't think that we are using some substitution method. This is the only possibility, no other possibility, because of the range of the function. Hence here what we have taken is, what we are going to take is each of the values sin theta I equal to how much here? 1 for all I belongs to, or I equal to 1, 2, 3 etc. n. In this way try to write short ways. Instead of writing sin theta equal to sin theta 2 is sin theta 3 etc. just represent like this. And after writing this value is possible. One of the values, if I take theta I equal to how much now? Pi by 2. It may be equal to 2 pi plus pi by 2, or it is 4 pi plus pi by 2. Like that any other value also may be exist. Now here what about correspondingly this? Again I is 1 to n. Okay. Now they asked you about sigma cos theta I. So sigma cos theta I means I values they gave here from 1 to n. Hence this is nothing but cos theta 1 plus cos theta 2 etc. It is plus cos theta n. Okay. And at this stage if I substitute each of the values, cos 90, cos 90, cos 90, like that, you will get how much finally? 0. Okay. So whenever it is given number of terms is n on the left hand side, RHS answer is n, therefore the only possibility is nothing but each theta I equal to nothing but how much here? Pi by 2. That is the only possibility, and this you came to know only as you know about range of sine function. In the same way the second problem you observe. Second problem they gave sigma cos theta I, that means they gave here cos theta 1 for second problem, cos theta 1 plus cos theta 2 plus cos theta 3 etc. is equal to plus cos theta n. This value they gave here n. Now once this is equal to n, then what are possibilities? Each must be equal to again and 1 only, because of the reason as sine in between -1 to 1, we have observed even cos also in between -1 and +1. However, theta you substitute least or largest value, so that what we are going to find here, each value equal to 1. So cos of theta I equal to 1 for all I values. What are I values here? 1 to etc. n. For all I values 1 to n, cos theta I equal to 1. When it is possible, each of theta I is equal to 0. For all I, again 1 to n, each theta I equal to 0. Or you can use here other values. That means what are other values here? 2 pi, 4 pi, whatever other values even you can use also, no matter. And now I will substitute all values in the required one. What is the required one? Sigma sine theta I. And what is sigma sine theta I? It is sine theta 1 plus sine theta 2 plus sine theta 3 etc. till where we can write here up to here n. Now what is each theta I here? 0. Therefore, if you substitute 0 plus 0 etc. 0, simply you got the answer how much? 0. Understand students? So these two problems, first one and second one, we did based on what concept? Range of sine function and cosine function. Now let us check about third problem. Read all of you, what is the third problem actually? Sine 170 degrees plus cos 170 degrees. Whenever, any time if you find other than acute angles, then no need of going for the higher values. That means 170 means it is actually belonging to which quadrant? It is in second quadrant. And in second quadrant, what are the values? Instead of taking all that, better whenever you observe this type of values, better you reduce them in smallest acute angles. So how to write smallest acute angle? First I start problem as A equal to sine 170 degrees plus this is given as cos 170 degrees. Okay. So after you write A equal to this value, now I am going to reduce in smallest acute angle. For that purpose I am using again 180 minus how much here? 10. Understand? Plus this is cos 180 minus 10. Just only one step. Understand? After this we observed allied angle concept. 180 minus this is theta. Sin 180 minus theta equal to sin theta, that is 10. Okay. And after that this is 180 minus theta. Cos 180 minus theta, what is the value? Second quadrant. Therefore this is minus cos 10 degrees. Got it students? And now how I can find this value? Then one of the methods, just based on graph. What is sine graph? We have observed the sine graph is from here to here. This is 0 and this one where it meets again x axis at pi, and this one is what here? Pi by 2. This one is nothing but sine graph. This is y equal to sine x, and 90 means this is here pi by 2 means 90 degrees. And next cosine graph. Cosine graph I am taking as a dotted one. So this is our cosine graph. Okay. So these two curves, they are intersecting. Where they intersect, you know clearly these two intersect exactly at x equal to 45 degrees, because sine 45 degrees same as cos 45 degrees, and this value is how much it is? 1 by root 2, and therefore this is exactly which kind of value? It is pi by 4. Pi by 4 means what is the value? 45 degrees. And what is the value correspondingly here? 1 divided by root 2. Now observe, this is your, the dotted one is nothing but here the cos value, and this is our sine value. So now here if I draw like this, this is 1 and here 1. Students, you observe this is 45 degrees. Okay. Now 10 degrees, where it will come, just left hand side of 45 degrees. Now observe, this is somewhere here you can find cos 10, and somewhere here you can find sin 10, and ordinate value sin 10, this is sin 10 only, this part, the vertical length, ordinate part, and this one is here cos 10. So which ordinate is more? This ordinate is more, cos ordinate, this is more, and whereas sin is here, compared to it less. Therefore sin 10 minus cos 10, what is our answer? Clearly less than 0. Okay. So 45 degrees is falling this side, 10 degrees where it will be just to the left hand side, and this one is nothing but your 10 comma cos 10 degrees, and this one is here, this point is nothing but 10 degrees comma sin 10 degrees. Okay. And this point, the vertical part, if you observe, this vertical part is more compared to this vertical part, and hence we can observe sin 10 minus cos 10 obviously negative. Got the students? So like this here, directly just have a glance on graph and immediately this side it is coming, and it will take very less time, as this is the first problem based on graphs. So I explained, that's why it takes time. Otherwise, suppose if you want to solve after rigorous practice, immediately you can say it is negative. Now let us check here the fourth problem. What is fourth problem? The fourth problem is nothing but 130 degrees. Now that one also here obtuse angle. So that obtuse angle, just like this problem, let us reduce in exactly here acute angle, smallest acute angle. So x equal to, this is the fourth problem, sin 130 degrees, 130 degrees plus cos 130 degrees. Now this 130 I am writing as 180 minus 30. Okay. So this 130 we are writing as 180 minus 30, and here also I am writing 180 minus 30. Okay. Now 180 minus, 180 minus, this is 50, and this one is again 180 minus 50. Now if you observe, 180 minus this is your theta, therefore the answer is here sin 50 degrees. Okay. And next, again if this is our theta, 180 minus theta, second quadrant, therefore what is the value? Minus cos 50 degrees. Okay. So you got sin 50 minus cos 50. Earlier we got in terms of 10. This is 45 degrees, and here exactly sine curve, cos curve, both are intersecting. This is the point of intersection of sine curve, cos curve in first quadrant, 45 degrees. The previous problem value is towards the left side of 45 degrees. Now this problem 50 degrees, it is falling exactly to the right side of the value 45 degrees. So right hand side, if you observe the 45 degrees, this is 50 degrees. Now this is suppose exactly that value. Understand, if this is our 50 degrees, understand students, 50 degrees if I mark here, if this is 50 degrees, now what is this curve here? Sine curve. So 50 degrees comma, how much it is? Sine 50 degrees. And what about this curve? Dotted one is our cos curve. This dotted one, here it is 50 degrees comma cos 50 degrees. So which ordinate is here? Length one here, lengthwise sin 50 larger value, cos 50 smaller value. So what about this problem answer here? Positive, because of nature of this one. Sin 50 is more compared to cos 50. So you should be very conscious while solving these problems using graph. Now the previous problem, just 45 degrees left hand side, if you find the value 10 degrees, and now here it is to the right hand side, exactly reversal value we got, because the two are intersecting at 45 degrees in first quadrant. So students, like this, just if you draw graph, you can find easily these two problems 3 and 4. and different other methods also there to solve these using multiple and submultiple angle also. And next let us do here fifth problem. What is the fifth problem? Just read once. The fifth problem is nothing but for every x belonging to R. See, whenever any problem, students observe clearly, any problem, any conditions given, you should read the problem thoroughly. Okay. So usually our concentration is only on the some equations, only on some equations. This is the equation, so immediately I want to solve like this, our mentality will go. But you have to read the total problem. What is the total problem? For every x belonging to real number. So whenever you find any such conditions while solving problem, immediately underline it, okay, because in a hurry while doing the 30 problems or 20 problems in our exam will be very hurry. So to avoid that, while reading it itself, you just underline so that you cannot miss any of the points, okay. So now for every x belonging to R, cos theta equal to x plus 1 by x given. Whatever x you substitute suppose 1 by 3, you substitute minus 1 by 2, you substitute root 2, minus 2000, 2010, like that any value x real number you substitute. Of course 0 not valid, okay, because 1 by x defined only when x not equal to 0. That is why here suppose you leave 0 and any other real number you substitute, can you get cos theta of acute angle, obtuse angle, right angle, or no such theta is possible. Now whenever these model problems are given, then we follow clearly the condition from here range, understand. So first let us take the equation, x plus 1 by x given as how much here, cos theta, okay. And here other formula also there, AM, GM, etc. But now I am doing in different, many models are there, I selected another method. I am just taking here LCM, x square plus 1 divided by x is how much here, cos theta, okay. So equal to is there, just cross multiply, x square plus 1 is equal to how much here, x cos theta. And now write this value towards this side. Then x square minus x cos theta plus 1 equal to 0, okay. So we wrote up to here. Now to find suppose x they said real number and you got a quadratic, and they said real number, that means what should happen, the discriminant must be greater than or equal to 0. So I am taking here discriminant, that is b square minus 4ac, okay. So you know very well all students about quadratic, x square coefficient, a is 1 here and b is minus cos theta and c equal to 1, understand, because what is happening here, it is a quadratic in not theta, it is a quadratic in variable x, that is why x belongs to R given. So we are using the concept discriminant greater than or equal to 0. And now then what will happen, cos square theta minus 4 greater than or equal to 0. So that cos square theta you got greater than or equal to how much, 4. But what cos can here take, only in between minus 1 and 1. But how much you got, more than 4. That implies here cos values, they are less than or equal to minus 2 or they may be cos values greater than or equal to 2. Any of these can be possible. Now you observe it is not at all within the range of cosine function. Cos value, this cos value, it can take only values in between minus 1 and plus 1. But how you got all values now? You got values, actually it has to be only minus 1 to 1 cos can take these values. But how we got values, 4 here and this side minus 4 here, after taking square root minus 2 and plus 2. All values they are from here onwards or from here onwards. But these values cos any time, whatever theta you give, cos cannot take. So how again we have solved this problem basing on the concept of range of cos function. Understand students, that is why here the range of trigonometric functions, the graphical knowledge, all these are very important. So students, earlier we observed regarding cosecant and the sine and cos. Now let us check about cosecant and secant. Observe cosecant square alpha in first problem given as 4xy by x plus y whole square. Again, as I said, you should read complete conditions carefully. X comma y both given 0 0, that means they are not 0 0. X is not 0, y also not 0. And then the question is here, cosecant square alpha, if this is real value, then it is possible from whenever x is equal to y, and it is not at all possible if you put x equal to y, and it is possible only when x is minus y, and not at all possible for any of the real numbers x and y. So which options is here? Right, they are asking. The given value is what here? Cosecant square alpha, and this is the value. Total problem, the information you have to give about x and y. Okay students, now we will make use again here also the range of cosecant function. Even power is there, so no need of taking less than minus 1 etc. Directly we write cosecant square alpha. We start with the known value that it is always greater than or equal to 1. Always in the sense for all values from the domain of cosecant function. If you substitute, it is always greater than or equal to 1 because of the even power. I am not writing the other one, that is cosecant alpha less than minus 1. That is not necessary because of our even power. Now let us substitute cosecant square alpha here. If alpha is 100% real from the domain, then this inequality must hold good. Okay. So I am substituting now this value. It is 4xy divided by x plus y whole square greater than or equal to 1. Already they said x and y are non-zero. So nothing to worry about denominator 0 or anything. So now this is a positive value. Whenever a positive value is there, easily you can do cross multiplication. But if it is negative value, while doing cross multiplication, you have to change the inequality. It is positive, so directly I am taking cross multiplication. So 4xy greater than or equal to x plus y whole square. And now I will write this value that side, or 4xy greater than or equal to x square plus y square plus 2xy, and hence 0 greater than or equal to x square plus y square minus 2xy if 4xy goes to that side. This is a perfect square, and what is that perfect square here? X minus y whole square. That implies x minus y whole square, you got how much now? Less than or equal to 0. Understand students here? This is the value you got. If I write suppose 3 is greater than 1, then you can write it as 1 as less than 3. Understand? Easily you can here understand. So 0 greater than means that is nothing but x minus y less than or equal to 0. But what is the nature of even power of any value? Even power of any value, you know, always it is a positive quantity or else it must be 0. It can't be any time less than. Hence here less than or equal to. So whenever you take this value, it is less than. If it is less than, okay, you take it. Otherwise, what is the other chance? Or equal to. So now here you observe, it is less than or equal to means less than is not possible. So which one we consider here? Equal to. So x minus y whole square, you got how much here? Equal to 0. Implies x equal to how much here? Y. So whenever you got this kind of value, then it is possible only for which value? X equal to y, and they didn't mention x and y are unequal values etc. They did not mention. So as they did not mention, x and y must be distinct, so you can make use of this value. If you substitute x equal to y, let us substitute here x equal to y. Then what is the numerator? The numerator you will get here 4x square, denominator x plus x, that is 2x whole square, 4x square. So cosecant square alpha you got here how much? It is equal to 1, which is real value alpha equal to the one of the values you can substitute as 90 degrees. Understand students? So what is the answer to this problem? It is possible, that means the real value is possible for x equal to y. Now why they kept here the condition x and y not equal to 0? What is the reason? Clearly they mentioned in the problem. If I put x 0, y 0, you will get 0 by 0, which is indeterminate. That's why they kept here x and y both not equal to 0. Even suppose x is 0, y not equal to 0. Understand? X 0, y not equal to 0. Suppose you take this value, then what will happen here? X 0 if I put, this is 0, denominator you will get how much? X square or y square, a finite value. Understand? 0 by finite value, the answer is always 0. Cosecant square alpha equal to 0, but 0 is not in any range of cosecant function. That's why students, even here only one value 0 also, it is not at all a real value. So you should observe given condition very carefully. Okay. So finally what is our answer? Possible for x equal to y. Now let us check about the second problem. What is the difference between first problem and second problem? Okay. So this kind of analysis is every time very important. Here square value they have asked, that's why we started directly with cosecant square alpha greater than or equal to 1. Here it is not square, it is just asked as cosec, that means it will be less than minus 1 or greater than plus 1. And next what is the other condition given? Here they kept C unequal as well as non-zero. Here they didn't put any condition like x and y are unequal, whereas here they kept the condition x and y must be unequal at the same time non-zero. So again as I said, immediately just round up these kind of given conditions. Now what will happen if x equal to y? Suppose just like the previous problem, if x equal to y, then cosecant theta equal to how much? 0 divided by finite value. Again it is not defined because cosecant theta is either less than minus 1 or greater than 1. That's why here 0 is, that is x and y equal values, not possible like our previous problem. Okay. So here that's why they kept condition as x and y are unequal at the same time non-zero. So students, let us start the problem by taking cosecant theta equal to how much here now? The entire value, where cosecant theta first we start with less than minus 1 and the other one is greater than 1. Let us start cosecant theta less than 1. First I am taking this. Okay. What is the other one here? Or cosecant theta, this is less than minus 1 or cosecant theta greater than 1. Okay students. Now suppose substitute this value because it is given x square minus y square divided by how much here? X square plus y square less than minus 1, and this is a positive quantity, right? X square y square plus symbol positive, therefore directly you can do cross multiplication. So any time you can't do like this unless the denominator is a positive value. So I am doing here cross multiplication, x square minus y square less than minus of x square plus y square, and then it is x square minus y square less than minus x square minus y square. Okay. So now this is minus y square, just like our known algebra condition we cancel. Then take this minus x square towards this side. What is that? 2x square less than 0. Okay. So x square less than 0, so that is not at all real because even power always positive. 2 is positive value, so you got x square less than 0, which is not real. Okay. That is why here this is not possible. So, if you start with basing on the range cosecant theta less than minus 1. Now, you might have asked here what will happen equal to, why didn't you write? Okay. Suppose if I write equal to, okay, I will do, and here also if I put equal to, what happen again? X square less than or equal to 0. X square less than or equal to 0 means what happened here? X equal to 0 is the only possibility. But in problem they already mentioned x and y are non-zero. So, I cannot take x is 0 in this problem. But given here what is the condition? X not equal to 0. Non-zero values they are asking. Understand, students? So, finally from this case you didn't get any value of theta. Okay. Now, let us go again from this side also. Now, again as I said here, even if you start with equality, then what will happen here? X square minus y square divided by x square plus y square greater than or equal to 1. Hence, x square minus y square greater than or equal to x square plus y square. Freely I cross multiplied, again and again I have been repeating, because denominator positive, then only you can do cross multiplication. Cancel, then what happened? Minus y square went that side, 0 greater than or equal to 2y square. Again you got y square less than or equal to 0, and this is again wrong. That is why y equal to 0 is the only possibility. Again they said don't take y value also 0. So, here but y is not equal to 0 from data. So, here also we did not get any of the values. So, what to do now? Finally, there is no such theta exists. Do not misunderstand, these problems are just answer we can kept no real value of theta, but here you got no possible value for x is y, because they did not mention x and y are distinct, whereas here they kept extra condition x and y are distinct, at the same time x and y should not be 0. Suppose if I write here only one of the values 0, only x 0, y should not be 0. Okay. Let us check, then also any objection will come, only x 0, y not equal to 0. Then what will happen? Cosecant theta equal to x 0. So, minus you got y square divided by what is the denominator you got? X square plus y square. So, you got y square. So, cosecant theta how much you got here? Minus 1. Understand? So, only one of the conditions if they keep, then you can get some value. That is why here you should read the problem very carefully. Not only the equation, your concentration should be on the other part of the given equation. So, students observe here this problem, the greatest among all these values, sine 1 plus cos 1, root sine 1 plus root cos 1, sine 1 minus cos 1 and 1. Among these 4 quantities, which one is the largest value? Understand? Now, do not understand, I forgot to write degrees here. Okay? I did not write degrees. The meaning is it is radian. Okay? It is radian, and 1 radian is approximately equal to 57 degrees. Okay? So, 1 radian it is approximately equal to 57 degrees. So, in any problem if you find like this sine 1, do not understand it is a printing mistake. Okay? It is not printing mistake, it is represented in terms of radians. So, sine 1 means nothing but how much here? Sine 57 degrees. And now next value cos 57, root sine 57, etc. they are asking. Now, how to find here exactly? We don't, they never allow any calculators or any computers or any other thing to us to find all these values. So, how to find? Then just by using our previous knowledge, that is based on graphs or any other value algebra, you can easily just check which one is here the largest value. Students, I think all of you know, suppose if I write root of it is 100, understand what is this value? It is 10, okay, a positive value, you know about this one. And how is this quantity actually? It is more than 1. So, whenever this is more than 1, root 100, you clearly observe it is less than 100. Understand students? Clearly root 100 is less than 100, that is 10. 10 is less than 100 when the quantity is more than 1. Suppose if I take here under root of 1 by 100, okay, 1 by 100 I took. What about this value? It is 1 by 10. 1 by 10 means what is this value? 0.1, which is less than 1. So, root of 1 by 100 I am comparing now with which value? 1 divided by 100. Okay. With this I am comparing because inside the value and this both are same. Now which one is larger and which one is here smaller? I am just comparing root 1 by 100 and 1 by 100. Okay, then now you observe this is 1 by 10. Okay, so 1 divided by 10 and this is 1 by 100 and this is 0.1 and this is 0.01. Therefore, what is the large value? 1 by 10 is the large value compared to 1 by 100. Therefore, here this is the large value. And how is this value here? Inside the square root, this is a value less than 1. Inside the square root, this is the value greater than 1. So, the problem here basing on this one. So, if I take root of x, understand students, root x, it is always less than x when x values are greater than 1, clearly from this kind of example. And root of x value, it is greater than x when 0 less than x less than 1. Why I kept here 0 less than? Because square root value defined only for inside, the value must be positive. So, whenever 0 less than x less than 1, root x value is greater than x and x greater than 1, the root x value is less than x. Of course, when x is equal to 1, both are equal. So, nothing to worry about equality. Now, let us come to this problem. Okay, students, what is here range of sine function? The range of sine function is here between -1 and +1. That means, if I take sine 1, that means sine 57 degrees approximately. Sine 1, you understand it is acute angle, therefore it is 0 less than sine 1 less than how much here? 1. Got students? Because it is 57 degrees approximately, hence we can understand it is a positive value between 0 and 1. That means you observe sine 1 is a value less than 1. As sine 1 is less than 1, therefore what about root of sine 1? Okay. So, root of sine 1, definitely it is greater than how much? Sine 1, because sine 1 is here less than 1, positive as well as less than 1. Hence, we got root of sine 1 is greater than sine 1. Then, what about here sine 1 and sine square 1 relation? Okay. So, if I take 0.1, a value less than 1, then 0.1 whole square. What is 0.1 whole square? 0.01. So, which is here? This is x suppose and this is our x square. So, when x is less than 1, x square is here, compare these two values, x square always less than how much here? It is x. Understand? That implies x is greater than which value here? X square. Therefore, sine 1 is greater than which value here? Sine square 1. Got students clear now till here? Observe x value 0.1 which is less than 1. X square is how much here? 0.01. Understand? That means here x square value less than x. If you just reverse x greater than x square. So, this is all when x values are less than 1. Hence, you got sine 1 value greater than sine square 1. Therefore, I am taking directly root sine 1 greater than how much here? Sine square 1. In the same way, because cosine also having same kind of range, moreover 1 is nothing but acute angle 57 degrees. So, same rule applicable even for cosine also. So, now we are taking these values also. Got students? So, root sine 1 here, sine square 1, And again here let us take these other also, same relation, you can continue here. Now all values here, all are positive, so if you add the inequalities, inequality remains same. So one of the important points is, whenever you are having inequalities, if at all you want to add, make sure the quantities are positive. If they are positive, directly you can start here addition. So I am adding, then same inequality continue, that is root sine 1 plus root cos 1 greater than sine 1 plus cos 1, and this is greater than how much here, sine square 1 plus this is cos square 1, therefore it is 1. Got students now? So root sine 1 plus root cos 1 greater than which value, sine 1 plus cos 1, which is greater than which value, 1. Hence what is our complete here conclusion, root sine 1 plus root cos 1 is obviously greatest among all these 4 values. Then you might have asked here, what about sine 1 minus cos 1? Clearly it is a minus symbol, here it is a plus symbol. We observed already root sine 1 plus root cos 1 is more than the addition, positive value, and you added, understand. So this is already positive, it is more than this, so obviously it is more than even sine 1 minus cos 1 also. So students, what is our now our answer? It is root sine 1 plus root cos 1. So usually while solving this problem, our tendency is anyhow root 4 is 2, so what we think, it is less than, and hence here obviously sine 1 plus cos 1 will be the largest value, like that. But the thing is, you have to check any problem, not only positive, sometimes you have to make use less than 1 also. What will happen if it is less than 1 positive, and what will happen if it is greater than 1? Understand students? So today we have discussed some examples regarding which one, graphs, range of functions. Practice once again all these, and tomorrow, that means in the next session, we will come with some more examples along with compound angles. Till the time, all of you just take care of all these problems once again, practice rigorously. Okay, thank you.